The Voyager mission is a tale of human ingenuity and unprecedented discovery. The two twin Voyager spacecraft have traveled farther than anything we've ever built. Let's dive deep into this amazing adventure that's been going on for over 45 years and is still making history. Picture this, it's 1977. Star Wars just hit theaters, showing us a fictional galaxy far, far away. While this was happening, NASA was preparing to launch two real spacecraft that would actually venture beyond our cosmic neighborhood. The Voyager mission was born during this exciting time, though its origins stretch back to the early 1960s. That's when astronomers realized a rare planetary alignment would occur in the late 1970s. This alignment, occurring only once every 176 years, would allow a spacecraft to visit multiple outer planets using a technique called gravity assist. And that meant the spacecraft would be using each planet's gravity as a cosmic slingshot to boost the spacecraft's speed. The Voyager spacecraft themselves are technological masterpieces, especially considering they were built with 1970s technology. Each Voyager weighs about 1,592 pounds, 722 kilograms. Each Voyager carries a computer with 69.63 kilobytes of memory. That's less than a single modern digital photo. An 8-track tape recorder for data storage, yes, like those old music players. A power system that converts heat from radioactive decay into electricity. A suite of scientific instruments that have far outlasted their expected lifespans. And the famous golden record, humanity's message to the cosmos. The engineering team faced incredible challenges. How do you build something that can survive the intense radiation near Jupiter? Is approaching absolute zero? Function reliably for decades without any physical maintenance and communicate across billions of miles of space. The team at NASA solved these problems with remarkable ingenuity. For example, they created triple redundant systems for critical functions and developed new materials to protect against radiation. The spacecraft's main antenna is a 3.7-meter dish that can transmit data at just 160 bits per second, roughly 1/28,000th the speed of a modern home internet connection. In 1979, both Voyagers reached Jupiter. And what they found was mind-blowing. Before Voyager, we had only seen Jupiter through telescopes. The spacecraft revealed a dynamic atmosphere with storms that could swallow Earth several times over. The first detailed images of Jupiter's Great Red Spot. Active volcanoes on Io, the first ever seen anywhere beyond Earth. A previously unknown ring system around Jupiter, lightning in Jupiter's atmosphere. And two new moons never seen before. The Jupiter flybys were nail-biting moments for the mission team. The radiation near Jupiter was so intense it could fry the spacecraft's electronics. They had to carefully choreograph each movement to get the data they needed while protecting the sensitive instruments. Next up was Saturn in 1980 to 81, and again the Voyagers transformed our understanding. They showed us the true complexity of Saturn's rings, revealing thousands of individual ringlets, discovered several new moons. Found a thick atmosphere on Titan, Saturn's largest moon. Observed giant storms in Saturn's atmosphere. And revealed the famous spokes in Saturn's rings, features that still puzzle scientists today. The Saturn encounters were particularly crucial for Voyager 1. After its flyby, it began its journey up out of the plane of the solar system, heading toward interstellar space. Voyager 2, meanwhile, continued on to make history. In 1986, Voyager 2 became the first and still only spacecraft to visit Uranus. This encounter revealed a planet tipped on its side, rolling like a barrel around the sun. A magnetic field tilted 60 degrees from the planet's rotation axis, 10 new moons, a system of dark rings, and an extremely cold atmosphere with supersonic winds. The Uranus flyby required incredible precision. The spacecraft was so far from Earth that commands took over 2.5 hours to reach it. Everything had to be planned months in advance. Voyager 2's last planetary encounter came in 1989 with Neptune. Despite being 4.4 billion kilometers from Earth, the spacecraft performed flawlessly, showing us the Great Dark Spot, a storm system similar to Jupiter's Great Red Spot. Geysers on the moon, Triton, shooting nitrogen ice 8 kilometers high. The fastest winds measured in the solar system at 2,100 kilometers per hour, 5 new moons, and a system of rings made of unusually dark material. After the Neptune flyby, both Voyagers began a new phase. The Voyager Interstellar mission, often referred to as VIM. This is where the story gets even more interesting as the spacecraft ventured into unknown territory. To appreciate what the Voyagers are doing now, we need to understand our solar system's structure. Imagine our sun sitting in a giant bubble called the heliosphere. This bubble is created by 1. The solar wind, a constant stream of particles flowing from the sun. 2. The sun's magnetic field, which gets carried out by these particles. And 3. The pressure of interstellar space pushing back against this outflow. This bubble has several layers. First, the termination shock, where the solar wind suddenly slows down. Second, the heliosheath, a turbulent region where the solar wind gets compressed and chaotic. And lastly, the heliopause, the actual boundary between our solar system and interstellar space. Both Voyagers have now crossed all these boundaries, making history in the process. Voyager 1 hit the termination shock in December 2004 at 94 astronomical units. It crossed into interstellar space on August 25, 2012, at 122 astronomical units, becoming the first human-made object to leave the solar system. Voyager 2 reached the termination shock in August 2007 at 84 astronomical units. It entered interstellar space on November 5, 2018, providing a different perspective due to its location in space. The Voyager mission isn't just about scientific instruments and data, it's about people. The team that manages these spacecraft has evolved over generations. Some current team members weren't even born when the spacecraft launched. They've had to learn and maintain code written in outdated computer languages. They've developed innovative solutions to problems nobody anticipated. They treat each spacecraft almost like a family member, knowing their quirks and personalities. Each Voyager carries a golden record, a time capsule of humanity containing 115 images of life on Earth, greetings in 55 languages, 90 minutes of music from various cultures, natural sounds from Earth, and messages from then-President Carter and UN Secretary-General Waldheim. These records were curated by a team led by Carl Sagan and are expected to last over 1 billion years. We hope you've enjoyed this journey through our solar system with Voyager 1 and 2. And we invite you to join us on our next video, a deep dive into some of the fascinating images the Voyagers return to Earth.